Okay, good morning for those that are online. We're just going to wait a few more minutes, a few more seconds for people to load up. Um, we will be with you in just a minute. Okay. No mai, haere mai. Welcome, greeting to everybody that has joined us from around the country. I hope the weather in your part of the world is playing ball with you. Thanks for joining us this morning. Uh, Today's subject is the brick seismic connections used in conjunction with external insulation and how these are used more commonly in commercial applications. My name is Mike Skelton, and I'm the General Manager of Outright Continuous Insulation. We thought today's topic would be of interest as brick has been used for many decades in various forms. More recently, the manufacturers have upgraded their ranges, sizes, and colors, and this has made it more attractive option for robust facade designs. We now see bricks being used in a wide range of buildings around the country, and we thought that you would like to understand the options for building maybe in a higher, larger scale or in quake-prone areas. To our panel today, we're fortunate to have some experienced speakers, and this starts with Peter Raimondo, who is a building enclosure engineer and also a director of Oculus Architectural Engineering. Peter is a highly experienced facade engineer, originally from Canada. For those that don't know him, he studied in Canada, in Toronto. And for those that watch movies, I wonder if we should call him the man from Toronto. Peter, Peter has
Maybe.
built. Sorry, Pete.
I said maybe.
Yeah, maybe. Yeah. It was a great movie if anybody hasn't watched it.
Yes.
Uh, Peter has built a strong reputation for delivering robust and viable facade solutions around the country. And with a career spanning numerous high-profile developments, he's worked closely with architects, contractors, and consultants to integrate facade systems into the overall building design. His strength lies in navigating, all the key requirements, risk management, and maintaining programs, and budgets is really important as far as the role goes for Peter. Now, joining Peter today, we have one of my colleagues, Angela Duthie. Angela is our technical manager at Outright Continuous Insulation and is a pretty seasoned building product specialist with a decade of industry experience across many disciplines. She's really developed a strong reputation for technical expertise. She's quite focused on thinking and great client support. The evolving demands of modern construction is enormous, and she's quite passionate about delivering, good quality products, for durability and sustainability. She works really collaboratively with our industry, and it makes her a really valued partner for your projects. You've pretty much heard enough from me, so we're going to go to our first poll today. We're just going to bring this up. So the first poll, have you specified external wall insulation before? And if you can just take a couple of secs just to populate that, and then we'll move forward.
Yeah. For the record, I have, in case you're wondering my opinion on that one.
Excellent. I don't think you're allowed to participate, but
I'm
you
not.
stick that in. Okay, that's great. So we actually have a reasonably high proportion of participants today
Cool.
that have actually specified external insulation, which is excellent because it's really moving the dial, from an insulation model that was developed in the 60s and 70s in New Zealand. Our participants today are genuinely interested. And for those that haven't done it, well, hopefully today is going to be informative and insightful for you.
Mhm.
Okay, so first up, we've got Angela, and she's going to give you a bit of an overview about the external insulation uh, opportunities. Ange.
Thanks, Mike. So why use external insulation? So to start off with, MB made amendments in the last few years around H1 energy efficiency. However, the wall insulation have remained relatively untouched. So why is that? So if all they did on our walls was increasing them to 140mm, plus adding in R3.5 lofted insulation in the cavity, didn't consider air or vapor control, and there was no mechanical ventilation in there, it could potentially lead to leaky building 2.0. And why is that? This UBACUS analysis shows that risk of condensation in all these different structure types. You know, the lower one, which is the concrete strap and line, a Speckle have named it the wall of death due to the amount of condensation. Because it's hitting that cold structure, there's no way for it to escape. So, you know, there's quite a lot of risk in not thinking about it holistically. So also thinking about how important it is when you consider how much timber framing in our buildings. So that significantly reduces the performance of your internal insulation. So external insulation acts like a coat, so around the entire building, so minimise or even eliminating thermal bridges. So this way the insulation externally actually delivers nearly 100% of the thermal, the R value. Next slide. So what is Rockwool? So Rockwool is manufactured from melted volcanic basalt rock. So it's melted down, spun out like candy floss, and these thin fibres are laid in a way to create slabs in various densities. So it's non-combustible, so it won't burn up to 1,000 degrees. So really great for fire design and protection. And it also gives protection to other combustible and structural materials on the project. So Rockwool also has really excellent acoustic properties, and we can provide STC and NRC values for the standalone product. And also being vapor open. So being vapor open and water repellent means it won't absorb or hold moisture, it won't draw it in, and that long-term performance is unaffected if it does get wet. The higher density of Rockwool provides the rigidity and long-term durability, making it better suited to external wall applications. Rockwool Rain Screen is a variant specifically designed for external insulation with enhanced water repellency properties, plus great thermal performance as well. Next slide. So Enertherm PIR, what is it? It's a closed cell rigid polyisocyanurate. This has a high performance foam core and a multi-layer aluminium foil facing on both sides. So it delivers some of the best thermal performance for its thickness, while also offering high compression strength of 175 kPa. So that makes it a really good option for warm roofs, external walls, and even flooring. Because PIR is also highly moisture resistant, when the boards are installed correctly and all joints are fully taped, Enertherm PIR can be used externally. Actually, both PIR and Rockwool used externally don't require an additional building wrap over top. They can actually leave that off. Next slide. So the perfect wall. Joe Stubrick, he developed the perfect wall, and that ensures that all of the control layers are continuous and in the right place. So in order of importance being rain, air, vapor, and thermal performance. So rain is always the starting point. Nearly all claddings leak at some point, so they're technically rain screens. That means your real protection is the cavity and your weather resistive barrier. That's your last line of defence against external moisture. Air leakage is the next one. It can move, go back the slide. So air leakage can move 10 to 100 times more moisture than vapor diffusion, showing why it is more important on the risk scale. And vapor control, it can be climate specific, but we need to ensure that that wall dries out, whether to the external, which is what Rockwool will do, or whether with a continuous ventilation system internally. So Rockwool and Enertherm PIR are high performance rigid insulations, perfect for external insulation. Wrapping the building reduces the internal temperature extremes. So that's reducing your condensation risk, but also helping to extend the life of all your structure and your components as well. So warm roofs and external insulation create comfortable and larger living spaces while also reducing heating and cooling demand.
Excellent. Thanks, Angela. I mean, it seems quite specific for external insulation and the product types that are being used specifically in that. Look, how long does Rockwool last as an example? Is it going to hang around for a bit?
Yeah, so in Europe, Rockwool's been around for a very long time. So they did a Euroma study that took the product off the wall and retested it. And that product was 65 years old and the performance was the same as when it had been installed. The other good thing is you could reuse your product, but also Rockwool can be used to grow seedlings in as well. So any offcuts or old product, you can still use it as a growing medium.
Okay, I understand. So it's gonna last the test of time. It's been around a long time. It's made of stone,
Yes.
and it's a good fit for this type of application. Excellent. Peter,
Yes, sir.
the man from Toronto.
That's me. Not
That's
Kevin Hart,
you.
but another guy from Toronto.
Maybe Woody Harrelson, perhaps.
Yeah, maybe.
So yeah, I'm going to chuck the ball to you now, and to get some really good insights into how we bring all this together, making sure that it's going to do what it says it does. So over to you.
Yeah, absolutely. We got a fun little picture on the screen, a little bit scary. It's a view of some damaged, this looks like concrete brick as opposed to clay brick, but brick nonetheless. Veneer on a Gisborne house that must have had some sort of seismic event. And this is scary because, you see the big cracks there. And as you can see, the cracks, I guess, emanate from the bottom corner of that window and kind of go through the mortar joints upwards. And that's pretty typical for any sort of brick, stone, some sort of veneer like this on the outside of a building. And now it's scary to look at. And it might be tempting to think that, oh, if we use brick or stone or something like that, then we can't accommodate seismic movement. But that's not really the case. There are definitely ways to accommodate that movement. You just have to make sure that you allow for that movement. Now, the two-part ties are designed to accommodate movement, which is kind of a little bit different than a traditional strap tie. Because there's two parts, they actually are able to move without getting damaged, without dislodging from the brick mortar, and they just accommodate that movement a lot better than a traditional tie. If we go to the next page, you'll see some testing from brands on a two-story building. You can see it's pretty typical New Zealand construction. You have timber stud walls on the interior side. You have a brick veneer on the exterior side. And they've racked or shaken this building side to side about 3.5 times the actual design level, which is why you see those gigantic cracks, once again, emanating from the bottom corners of the windows and from the top corners of the windows. Just to kind of go back on that, those are the stress concentrations. When you have a hole in the brick, the corners are kind of where the stress, I guess, concentrates, and that's where the cracks are made out from. But yeah, this test here is showing a very extreme example, but it's really just to be more visual, because even at the one times the design level, the design level that you're supposed to design for, those cracks will still be there. They just won't be as wide. And that's just kind of how brick veneers tend to work. If you get a seismic event, you'll probably get these cracks in the mortar joint. They may be big, they may be small, they may open, they may close, but that's the damage that you'll see later on in the lifetime of a building. Now, when you're using a two-part tie, it'll kind of accommodate that a little bit better. But before we get to that, our next slide shows, I guess, the general seismic regions or seismic areas in New Zealand. And you can see there's different places that have more seismic movement and places that have less seismic movement. You can see green, yellow, red, pretty self-explanatory. But the typical way that you would design a brick tie is you're choosing either a type A tie or a type B tie. Type A is non-seismic, type B is seismic. And then you have low, medium, and high strength ties. Now, that's kind of a little bit of an oversimplified way of looking at it, but you have to have something in the design standards to kind of make it easy. But with the traditional strap ties, the key thing, even with a type B tie, which is a quote unquote seismic tie, it's still one piece of metal that you screw into your stud, and then that piece of metal goes into the mortar joint. And to accommodate seismic movement, it is bending. The steel is bending, the steel is deforming, or it's dislodging from the mortar, which is, a way to accommodate seismic movement, but it's not necessarily the most durable, the most redundant, the most robust way to do that. And if your seismic ties are being damaged or deformed after a seismic event, are they really something that you can rely upon later on? Sometimes yes, sometimes no. Depends on the seismic event. And there's lots of evidence in New Zealand's history on which ones did, which ones didn't perform, and in which conditions they did and did not perform. Now, contrast that with a two-part brick tie, which we'll see on the next page here. You can see that there's two completely separate components. You have the thermal L plate that gets attached to the wall. You see there's 3 screw holes there. In certain, depending on the zone that you're in, depending on the height of your wall, depending on a whole bunch of things, project specific, you'd be either using 1 screw, 2 screws, or 3 screws. In a lot of cases, especially in Auckland, 1 screw is more than enough. But you can see that there is that L plate which gets attached to the wall. There is a V tie which is separate from that and slips into that slot. And what that means is that your V tie, which is connected into the brick mortar joints, can move back and forth, and it will go back to normal without damaging anything because it has that accommodation. It slides back and forth. The nice thing about it also is that you have an up and down slot, and that's not to accommodate seismic movement. That's just for construction tolerance, which means you can install a bunch of these brackets before the brickies have even gotten there. And then as the bricks go up, you can put the V tie into the correct mortar joint, and it kind of gives you that construction tolerance up and down, which is pretty nice. And then the insulation support is another good portion as well. So yeah, here you can see an example of how that would be installed. You have the bracket installed to the stud on the interior side. You can see it's got 2 screws there. That goes through the insulation, and then the V tie is embedded into the mortar joint. But before that, it's slotted into the slot in the bracket. You can also see that there's the yellow tab there that holds the insulation on. And the nice thing about that is that it doesn't make things more complicated. You put your bracket on, you put your insulation on, you put your insulation holder on, and then you put your V tie on. And that's what holds your insulation, instead of having to put extra screws, stick pins, battens, et cetera, et cetera. You don't have to glue it on or anything like that. The brick tie is doing that work. So it's not really adding cost and adding complexity. It's all kind of just an all-in-one off-the-shelf product, which is pretty cool. But the key thing to remember here is that because you have a flexible structure, typically here in New Zealand, we use timber studs. Those are very flexible in comparison to brick, which is very rigid. And so instead of tying them together very rigidly with one piece of metal that is embedded on both sides, having the 2-part ties allows the studs to move behind that brick without imparting extra forces into the brick and possibly causing that extra cracking that you saw on those previous slides. So yeah, pretty cool product. We've been using it in Canada for a long time, but it seems a little bit new here in New Zealand, but it's not new technology. It's very, very well used elsewhere in the world.
Peter, thank you. That was a tremendous overview for that part of the segment. I have so many questions, but just thinking about it, for our audience, if they have any questions, please feel free to ask them on the chat function at the bottom of your screen there. And at the end of the session, we'll have a bit of time to hopefully go through some of those questions. So please feel free to ask a question. We have the people here to be able to cobble together the answers.
Yeah.
And of course, if there's anything offline that you want to take, we can accommodate those questions after the event as well.
Yeah.
So just very quickly, I've got a couple of quick ones for you. The yellow plate that sits on the outside of the insulation,
Yeah.
is that movable? Can that accommodate different thicknesses of insulation to provide you with options around your thermal capability?
Yeah. I mean, it's a compression fit little kind of gasket almost that goes on the outside of there. But when you're using different thicknesses of Rockwool, of external insulation, you also want to vary the size of that bracket to match, because you only want to have a certain amount of cavity between the outside of the insulation and the inside of the brick. So vary the bracket size, and then also you'll get construction tolerance with the yellow plate that holds the insulation on.
Yeah, sure. And detailing would pretty much be the same, around windows and soffits and multi heights of construction.
Yeah. Generally, detailing is same-ish. When you're going with a high-rise building or a mid-rise building and you want to put brick on it, you have to put a lot more seismic and accommodation joints. So I'd be putting horizontals at each slab level. I'd be putting some verticals at any corners or anything like that. Any long expanses of bricks, you have to put some sort of movement joint. Sometimes around windows, I'd also be putting some movement joints or some joint reinforcement possibly to control that cracking. But the two-part brick ties, if you have enough movement accommodation with sealant joints, then you'll be able to accommodate that movement without damage of the brick or the mortar.
Okay, I understand.
Yeah.
And just lastly, before we throw back open to the next part of the presentation,
Yeah.
is it easy for architects to specify and get compliance to the code?
Yeah, generally it is. If you're just using it on a small, 1-2 story home, basically you're just swapping out the brick ties. I believe you guys have some data sheets and engineering judgments that we came up with a few years ago. But yeah, you're using the same spacings. You're using basically the same kind of detailing that you would for any other brick tie, but you're just using a two-part brick tie instead of a one-part brick tie. If you're going for a bigger building, you may want to get me or any other enclosure engineer involved, just because there is some detailing stuff, larger flashings, those sealant joints, etc., that you'll have to worry about for a taller building that has more movement than a small single-family home. But yeah, generally pretty easy. And for compliance for a small home, generally easy.
That's excellent. Thanks, Peter.
No problem.
And just lastly, are there any restrictions around height for a brick building if you're using this type of system?
A hard restriction, no, but the taller you get and the more flexible you get on a building, the more difficult it is to detail. So if it's a fairly low, big square building that's not going to move very much because it's very stiff, fairly easy. If it's a very tall building that moves around a lot and you have little strips of brick, then yeah, it gets more difficult. But there's no like hard specific limit on it. You can kind of engineer your way out of almost anything.
Excellent. Now, look, we've got some examples now of completed projects in New Zealand. So if we flick to the next slide here, Peter, Somerset, St John's, and Auckland, if you've had some involvement in this, if you could take us through a wee bit of how this was constructed.
Sure. This is one that we worked on together. This is a big building. You can see it's 5 stories of brick. That cladding doesn't quite look very bricky in this picture, but I assure you that's all brick. And this looks like any other brick building that you might see around Auckland or anywhere in the country. But behind it, you have external insulation. You have the Rockwool insulation. And if you go to the next slide, we can see that actual construction. This is, I'm not sure if I took this or if my colleague Willie took this photo, but you can see there's a full layer of Rockwool insulation. You have the brackets coming through that insulation with the black insulation holder plates there. And then the V ties are going into the brick mortar joints there. You can see there's a lot of connection between those ties. and the brick mortar joint, instead of, you know, the strap ties. You only get kind of a little grab in there. But yeah, it's doable. It's done. If you want to go to St. John's, Auckland, and go take a look at the building, it looks like any other building, but it's externally insulated, which is really cool.
Just coming back to the brick manufacturers, I mean, they've really stepped their game up with colors and styles now. So they're, you know, a monolithic sort of finish for the buildings, and it's quite an attractive option for the design profession. That's excellent. Now, Ange, we're going to flick back to you because you've got a building that's a work in progress at the moment. Can you share some insights into this one?
Yeah, so Hillmorton Hospital here in Christchurch, they've adding on an adult acute facility. So this is the latest development on site for their mental health hospital. This project does have specified Rockwool externally, which when you've got sensitive clients really helps with not just the thermal performance, but you're getting acoustics, so added acoustic values from external to internal and vice versa, but also that fire protection too. So protecting all the structure and the buildings from external fire. If you go to the next slide, so this shows the detailing for Hillmorton Hospital. Now, the brick is obviously sitting on the outside, then the 50mm cavity, and then we've got 50mm of Rockwool, and then your brick ties fixed through to the structure, and that lemon insulation support is there as well. So all of these elements can be interchanged and be larger or smaller, so the L plate can accommodate it a lot wider insulation. We can also exchange the V ties for different sizes to allow for either larger bricks or larger cavity sizes as well. So it really can be, it's not just a one size fits all. So with this detail, you can see that they've got quite a lot of insulation on the internal. So Peter can probably talk to this a bit more, but when we look at it from a total, just a dew point wall system, generally we'll go 70% or more of the R value on the external versus 30% or less. But on this example, it has been fully envelope engineered, and they've got air tightness and I understand probably full mechanical ventilation there, Peter.
Yeah, you can see that there's the dotted green line there is water and air tightness barrier, good membrane in there. Yeah, like you said, the rule of thumb is, you know, 2/3 on the outside, 1/3 on the inside in terms of R values, but you can absolutely work outside of that as long as someone checks it. You have to do a woofy model, a hygrothermal model of some sort, just to make sure that it's all good for the specific place that you're putting it in. But yeah, if you don't want to think about it, you don't want to do those checks, you put 70% on the outside, 30% on the inside of the R value, and you'll be good to go.
Okay, well, that gives us a bit of a view of what's currently being built, what's currently being constructed at the moment, and there's ultimately a number of other projects in the works, in the design works as well. So we are seeing a history of use for this type of construction in New Zealand.
Yeah.
Look, we are getting bombarded with questions. It's really exciting. Thank you so much for people that are popping their questions in. We've got time for a couple of these, so let's just have a wee look at. So Barry's asked a question. If PIR is used externally, can they be issued? Is there any issues with vapor permeability?
Would you like me to take that one?
Yeah, sure.
Yeah, I mean, there can be issues, but if you use enough thickness of the PIR on the outside, you're getting rid of the dew point issues because you're keeping the inside warmer and above that dew point. But, you know, condensation issues can happen anywhere. If you let the inside of your building get super, super, super moist and super, super, super cold because you're not heating or ventilating, then there can be problems with any wall assembly. The PIR isn't going to be necessarily the thing that breaks it. But if you use a very small layer and you don't check the hygrothermal analysis of the wall, then hey, anything could happen. But use a thick enough layer on the outside and you're good.
Okay, thank you. Chris has asked a question I think was covered in your information earlier, Peter, but we'll just recant on that because I think it's important. So does the vertical slot allow the V-tie to move horizontally and vertically? But if it doesn't, how does it cope with horizontal movement?
Yeah, so the V-tie has like a horizontal section to it, and that horizontal section can slide back and forth into the slot. The vertical slot on the bracket itself is just for construction tolerances. You're not going to see that movement on a typical day in a building, but the left and right movement is accommodated by the fact that the V-tie and the bracket are not connected together rigidly. They're just kind of slipped in there, and it kind of just slips back and forth.
Okay. And another one from Dylan. What size cavities do the ties accommodate?
As much as you want.
Okay.
But
There's a minimum 20 mil or 50 mil?
usually you're putting like 40, 50 behind a brick. That's the standard. You can go down a little bit more if you have someone check on that there's not going to be any additional risks for whatever reason. You can make a really wide cavity if you really wanted to, but Angela, I'm assuming you guys have like specific, off the shelf sizes that you guys usually sell, yeah?
Yeah, absolutely. There's a lot of flexibility within that, making that L plate longer as well as the V tie. So we just check the engineering and calculations to make sure that it's all suitable.
Yeah.
Okay. Belin's asked a question which is really interesting because we're starting to see a lot more questions around this construction method. Can we install these cool ties into CLT panels? Is there a minimum thickness for CLT?
Yeah, you can definitely install them onto CLT. You can basically put them on whatever substrate you want, as long as you do have some sort of membrane or weather protective barrier or something like that. CLT, you have to make sure you keep water off of it. So as long as it's detailed properly, it's all good. In terms of the thickness, it really just depends on the strength of the building and the amount of embedment you get from this tie, the screw for that screw tie to go in there. But usually the CLT thicknesses are thicker than you would need for that screw because you usually only need like 40, 50, 60 mils of embedment, and usually the CLT is like 100.
Okay. Look, we have so many more questions that we can't answer today because we want to keep to time.
Yeah.
And I think we're getting pretty close. So we will take these questions and answer these back to you. So don't feel that we're leaving you out. We want to answer your questions and we'll come back to you. So thank you so much for your input to the Q&A session. We're just going to wrap this up by bringing up a poll. So if we could bring that poll up. Okay, so if you're working on a project, would you like a follow-up for the team? And by the way, if you do answer the polls, the second and the third poll, you will automatically go into the draw for the Building Sciences event that's going to be held next week across 3 venues in New Zealand. And it's a fantastic opportunity to listen to international speakers talking about building sciences. Well worth attending if you haven't already registered. So the poll will automatically the poll will automatically enter you. So please enter the polls. And our third poll is: would you like to win tickets to the Building Sciences Summit? And hopefully we'll get 100% people saying yes, amazing.
Yeah.
While that's been conducted, I just to summarize very quickly, look, if you have any questions, we have Oculus sitting in the background there that is able to answer any of your questions. Feel free to reach out. As we're moving and building smarter, better, there's 1,000 things that get raised. I think the important thing is that you have companies that are able to assist and work through some of the issues. Oculus certainly on the facade architectural side, outright on some detailing and peer reviewing and contractors and all of that sort of good stuff. So please feel free to reach out.
Yeah. Wonderful.
Okay. So on that note, I think we're just about there at time. I'd like to thank everybody for their participation today. This webinar will be available up online and will be posted to YouTube. So if your colleagues have missed this, feel free to log in. So on behalf of Peter, Angela, and myself, I'd like to thank you and wish you all the best for the rest of your day.
Thank you. Thank you.
Thanks, Mike.